All right, implement a queue using stacks. Implement a first in, first out queue using only 2 stacks. The implemented queue should support all of the functions of a normal queue: push, peek, pop, and empty. Oh, let's switch this over to Rust. Hopefully there's a Rust version of this one. Did I miss it? Uh-oh. Oh, there it is. Okay. I did miss it. Implement the myQueue class. Void, push, pop, peek, and empty. Notes: you must use only standard operation of a stack, which means only push to top, peek, pop from top, size, and is empty operations are valid. Okay. Depending on your language, the stack may not be supported natively. You may simulate a stack using list or dequeue, double-ended queue, as long as you use only a stack standard operation. Okay. And in Rust, stacks are basically vex. Vex and stacks are interchangeable. So we're going to implement the 2 stacks. Oh, that's right. We want to do this first. We want to do it here. This is problem 232. So that comes right between here. Pub mod lc 0232 implement queue using stacks. Do we use here? Colon star. We try to build, do the code action, create it, jump to it, and then copy and paste. Your myQueue object will be instantiated and called as such. Okay, so we could use this as our test case. Let's copy this, paste it here, and implement it. First we need to do test mod. Test ex1. And then I guess this is the same as the test case. Well, let's use this as a test case. This is a little more complex. Okay, so we're going to say let mut queue is equal to myQueue new. Right, that's what they're doing. Yeah, myQueue : new. So we have the new right there. All right. And we say queue push 1, queue push 2. And then we're going to peek, so we should be able to assert eq q.peek is equal to 2. Oh, is equal to 1. Because if we're doing a queue, right? And then we should assert eq q.pop is equal to 1. And assert that q.empty is false. Okay, so that'll be a decent test case, initial test case anyway. So in our struct, which we're going to have to say pub struct, unfortunately, because otherwise the library is going to complain. Right, if I just do this, self. Push doesn't do anything, pop returns 0, peek returns 0, and empty returns false. Let's just do that. Yeah, we're getting all these associated functions is never used. And the only way we can get rid of the associated functions never used is by making everything pub. So I'm just going to do that. Pub, 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 pub. Right, so now all those associated function errors go away. Help remove this mute. Oh, because these things need to be mutable. Okay, okay. So we'll fix that. So push, we need a mute self. Pop, we need a mute self. And for peek and empty, we don't. So we actually need the 2 stacks. Stack 1, vec of i32, and stack 2, vec of i32. So how are we going to implement the queue entries? First, we need to actually instantiate the stacks. Stack 1, vec new. Can I do it this way? Stack 2, vec. Will that compile? Expected expression. Oh, because I put a 1 there. Yeah, okay. And then, so push is, so we have to make a choice. Should we make push the slow operation, or should we make pop the slow operation? Leetcode, hello. Negvorsa says, in test, do we need to pop twice to be empty? Yes, we need to pop twice to be empty. And we can actually add those. 2, and then this should be empty. So we can certainly extend the test case like that. I don't know what we should return if we pop a queue that's empty. It might make the assumption that or it might be that the test cases all assume all calls pop to peak invalid. Yes. So they're all valid, which means we don't have to worry about running out of empty queues. We don't have to worry about popping an empty queue because there's no interface for popping. This should be an option, right? This should be an option. But without that, we can't do it. So, right. Do we want to make push the expensive operation or pop the expensive operation? Because the way to implement the queue is to always either have everything on stack 1, and then when we do a push, we just do a push to stack 1. And then a pop operation would mean moving everything to stack 2, popping the last item, and then putting everything back on stack 1. Or we make the push the expensive operation, where we want, in order to push onto the queue, we move everything from stack 1 to stack 2, we push onto stack 1, and then we move everything back. Let's do it that way. So we can just pop self stack 1 pop. While we have something, we say self stack 2 push, and we're done. And now we take the new value x and put it on the now empty stack, and then push everything back while let sum val self.stack, oops, 2.pop self stack 1.push val, boom. So that makes the pop operation very simple. We just say self stack 1 because everything is always going to be on stack 1. And then peak is the same thing, except instead of pop, it's last. Stack 1 last. And then empty is just self stack 1 is empty. I mean, what am I missing? I think I'm missing something. I'm missing the fact that this is an option. Same here. No more items. Oh, we have to deref it. And that's on, it's just on peak, not on pop. Okay. Look at that. Okay. So we can throw this at Leetcode and see if Leetcode likes it. Poke over here, paste, oops. Paste. There you go, accepted. Let's submit it. Ran in 0 milliseconds. Excellent. All right, so let's commit these changes. Problem 232, implement queue using stacks. Nice. Whoops. Not so nice. There we go. All right, that one's done. And now the final week 1 problem. Oh no, that was the final week 1 problem. There we go.